Thanks for watching Conservation Warriors. My name is Michelle Yan, and I am your host and tour guide. Today, we will be visiting Canada's Lake Superior, the largest freshwater lake by surface area in the world, to learn about the lake biome. First, a lake is a freshwater biome type that is sometimes called a lentic system, meaning still or standing water. Scientists and researchers of lakes are called limnologists. Lakes can vary in size, from a few square meters to thousands of square kilometers. Lakes are found everywhere throughout the earth. Some of the most famous lakes include Lake Erie, Lake Michigan, Lake Huron, Lake Superior, and Lake Ontario, the Great Lakes of the American Midwest and Canada. Lakes can be found at different latitudes. South Central Africa's Lake Victoria is found at 1 degree south, whereas Siberia's Lake Baikal, the largest freshwater lake by volume in the world, is found at 53.5 degrees north. Average precipitation and temperature ranges of lakes vary depending on their locations. Lakes that are located in mountains and valleys may have lower temperatures and less precipitation than lakes located on flatter terrain. Here are some examples of lakes at different altitudes. Burns Lake in British Columbia, Canada, at 713 meters of altitude, has an average annual temperature of 2.9 degrees Celsius. Temperature ranges from negative 14.2 degrees Celsius to 19.9 degrees Celsius, and total annual precipitation averages 455.9 millimeters. Detroit Lake in Minnesota at 421 meters of altitude has an average annual temperature of 4.3 degrees Celsius. Temperature ranges from negative 18.6 degrees Celsius to 26 degrees Celsius, and total annual precipitation averages 617.7 millimeters. Lake Charles in Louisiana at 6 meters of altitude has an average annual temperature of 19.9 degrees Celsius. Temperature ranges from 6.1 degrees Celsius to 32.4 degrees Celsius, and total annual precipitation averages 1,393 millimeters. These lake biomes have such different abiotic characteristics because the lakes are situated near or within regions of different biomes. Burns Lake is near a boreal dry scrub biome. Detroit Lake is near a cool, temperate, moist forest biome, and Lake Charles is near a subtropical, moist forest biome. Therefore, the lakes themselves also take on different temperature ranges and precipitation levels. Due to the large area that is covered by the Great Lakes, the soil in the Great Lakes region vary in nutrient levels and acidity. The southern lakes, like Lake Erie, are eutrophic, meaning that they are nutrient-rich. Their soils are thicker and contain mixtures of clay, silts, sands, gravels, and pieces of boulders that are deposited by glaciers that form the lakes. Consequently, the southern region is dominated by agriculture. However, here in Lake Superior, located in the northern region, soil is oligotrophic, meaning that it is nutrient-poor. The soil is a layer of granite bedrock beneath thin acidic soil. Some scientists call Lake Superior a distilled water ice bath because of its low amounts of nutrients, sediments, and large amounts of dissolved oxygen, all conditions that give rise to superb underwater visibility. The lake is divided into 4 zones: the littoral zone, the limnetic zone, the euphotic zone, and the benthic zone, each having distinct biological communities. The littoral zone is the near-shore, shallow area where sunlight penetrates all the way to the sediments, allowing aquatic plants or macrophytes to grow. The littoral zone is usually defined by light levels of about 1% or less of surface exposure, and it sustains most of the producers that are found in the lake biome, such as algae and other rooted and floating aquatic plants like flowering rush. It is also home to clams, fishes, amphibians, and eggs of insects. The organisms that live in the littoral zone are usually food for other creatures like turtles, snakes, and ducks. The 1% or less light penetration level also defines the euphotic zone of the lake. The euphotic zone, or photic zone, is a layer from the surface down to the depth where light levels are too low for photosynthesizers. Extending further out is the limnetic zone, an open water, well-lighted region that is surrounded by the littoral zone. Light usually does not penetrate all the way to the bottom in the limnetic zone. The limnetic zone is dominated by plankton, both phytoplankton and zooplankton, which make up the bottom of the food web in a lake biome. A variety of freshwater fish also occupy the limnetic zone. The benthic zone is the bottom sediment of the lake and has a surface layer abundant with organisms. The productivity of the zone largely depends upon the organic content of the sediment, including feces of organisms that inhabit the zone and soil nutrient level. Finally, the profundo zone is the deep water part of the lake where plankton fall when they die. The profundo zone is a region where little to no light penetrates, and it is much colder and denser than the littoral zone and the limnetic zones. The organisms that inhabit the profundo zone are heterotrophs that eat dead organisms like the dead plankton and use oxygen for cellular respiration. In addition to these 4 zones, a deep lake is often stratified into 3 layers as a result of water's density differences with temperature change. The top of the lake is called the epilimnion. The middle layer that may change depth throughout the day is called metalimnion, and the bottom layer is called the hypolimnion. Since cold water is denser than warm water, the hypolimnion usually has water that is denser than the water in the epilimnion. Lake Superior is dymictic, meaning that the water will be free to circulate from the surface to the floor twice every year. During the rest of the year, the water remains stratified based on water density. Other abiotic factors of a lake biome include temperature, turbulence, pH, nutrient level, oxygen, and light, all of which affect life within the water. Main producers in the lake include phytoplankton, periphyton, and macrophytes like duckweed and stonewort. Main consumers in the lake include zooplankton, fish that eat plankton, clams, and insects. Common predator-prey relationships of Lake Superior include the smeltfish-lake trout relationship, the lake herring native water flea relationship, and the algae opossum shrimp relationship. Here is a visual representation of Lake Superior's food web. For totally submerged plants, they often evolve to have weak roots because nutrients and water can be easily absorbed when the plant is fully in the water. The main function of roots become virtually for anchorage only. Many of the lake-dwelling animals have made biological adaptations over generations, the most significant of which is fish. Fish develop scales that are lined with mucus that protects them from harmful bacteria and toxins, as well as insulate some heat that is needed for colder temperatures in the winter. Human activities have significantly impacted lake biomes. At Lake Superior, the nutrient level of the lake has been fluctuating in recent years due to eutrophication caused by anthropogenic pollution. Also, humans burn fossil fuels, an activity which produces gas pollution. Sulfur released in the atmosphere precipitates as acid rain, which enters the lake biome and alters the water's pH level. This environmental impact harms lake-dwelling organisms, as many of them have a narrow window of pH level that they can live in. To address this issue, the U.S. and Canadian governments have passed a series of laws to limit the output of pollution in the Great Lakes region. But to further protect Lake Superior, more regulation needs to be enacted. Lake Superior is also a popular logging site. However, logging in the region removed tree cover that provided shade over spawning grounds, greatly affecting local temperature conditions. As a result, reproduction cycles of fish are disrupted and their populations fluctuate. To address this problem caused by excessive logging regulations should be put in place. For example, the government can issue limited logging licenses or quotas so that both human economic interests and the environment can be protected. Lake Superior is home to various endangered species, one of which is the piping plover. The piping plover hunts by sight, chasing down prey on the sand and grasping it with its beak. It feeds primarily on insects and small aquatic invertebrates. The piping plover's speckled coating has a camouflage function that helps it blend into its surroundings, which is usually sand. The piping plover is a small shorebird that inhabits the East Coast, Great Lakes region, Canada, and the Midwest of the United States. Currently, there are approximately 32 breeding pairs of piping plovers in the Great Lakes region, 1,398 breeding pairs in the northern Great Plains, and 1,372 breeding pairs on the Atlantic coast. Protective measures such as listing, management, and habitat protection are put in place to protect these birds. The U.S. Fish and Wildlife Service listed the piping plover as endangered in 1985 under the Endangered Species Act of 1985. Piping plovers here at Lake Superior and the other Great Lakes are listed as endangered, whereas those that nest along the Atlantic coast and northern Great Plains of the U.S. and Canada are listed as threatened. The piping plover's habit of nesting on open beaches leaves its eggs vulnerable to predators, beach construction, and human activity, greatly reducing its reproductive rates. Human access to nesting area is now controlled, nesting activity is monitored, and nests are intensely protected to help ensure the bird's successful nesting each year. Piping plover populations dipped slightly in 2001 before making a recovery in recent years since 2006. Therefore, it is safe to say that conservation has been a moderate success since plover populations remain more or less the same. Now that we have visited the beautiful Lake Superior and learned about the lake biome, I hope that you will visit more of the world's lakes in the future. I'm Conservation Warrior Michelle, and I'll see you next time. Thanks for watching.